Write each equation in exponential form. I just go through and realize I go through the equal sign, so 5 cubed, come back through, is 125. So it should be a true statement. Two raised to the negative 4 is 1 over 16. So this is the one you need to be good at. Natural log is what base? E. So this is really log. I'm going to rewrite this. Base E. Oops, sorry about that. Log base E of 2 is approximately 0.7. Or again, E to the 0.7 is approximately 2. They rounded it. I like those because those are quick. You think about homework problems that are quick? It's those. And then we have the ones where they want us to write it in logarithmic form, and that's where I have to think, but the base is the base is the base is the base. So it's log base 2/7 of something equals something. And it picks up the range value, which is 1, and returns it to the domain value, which is 0. And then log, the base is the base is the base is the base of something equals something, picks up, and it's actually approximate, picks up the range value, which is 1.649, and returns it to the domain value. And what do we know? We know that log base E is who? Natural log. So the natural log of 1.649 is approximately 1/2. Now, is there anything wrong with just writing log base E and keeping it that way? No, right? As long as you realize if you're going to put it in your calculator, you need to make sure that you understand the log base E is natural log. Yeah?
For like for C, would it be wrong to write it as like E raised to 0.7 equals 2?
E raised to
0.7 equals 2.
Yes, it would, because you're looking at an approximation. So if I actually do, the question ends up being, and let's see, second e to the 0.7, it's not 2. It's not 2. As being picky, of course.
Yeah. It's close, but it was-
Okay, here we go. Base is 6. So the base is easy, so you should always get the base right. You might screw up on the other stuff, but you should always get the base right. It picks up the 1 over 216 and returns it to -3. Like I said, sometimes it's helpful. I've a couple of times used this, but 90% of the time or even more, you're taking logarithms to exponentials, because the exponential equations are easy to solve. Logarithmic equations are not. It says to determine the value of each logarithm without using a calculator. Well, there's a couple of ways to come at it. What I normally do, I just set this equal to x, and then rewrite it. 3 to the x equals 81. And can 81 be written to a base of 3? Yes, it's 3 to what power? Equals 3 to what power? 4. So that x is 4. So we can say that log base 3 of 81 is 4. And by the way, this is in books. Do you think for 1 minute, if you're dealing with a application problem, that's going to be that clean? No. What's the base on this logarithm? 10. So I need to realize that the base here is 10. This is equal to x. So this says 10 to the x power is 1 over 10,000. Oh boy. I'm not used to dealing with so many zeros. I've got one too many zeros. Hide my error. Or 10 to the x equals 1 over 10 to what power? 10,000 is 10 to the 10 to the 10 to the 4th, because there's got 4 zeros. 10 to the x equals 10 to what power? If I went over 10 to the 4th, 10 to the x is equal to 10 to what power? Negative 4. Good old negative exponents. So that x is negative 4. Bases are the same. Exponents must be equal. So this tells me that the log of 1 over 10,000 equals negative 4. Is when you wonder where they come up with this one. But it's just getting you used to making transitions, that's all. Natural log is log base e, so this is log base e of square root of e is the same as e to what power? Square root of e is e to what power? 1/2. That's equal to x. E to the x equals e to the 1/2. So e to the x equals the argument, which is e to the 1/2. X equals 1/2. So this tells you that the natural log of the square root of e is 1/2.